Hi, this is Dennis Myers. In this video, we're going to show you the output of the Walk Forward Input Explorer. After the Walk Forward Input Explorer completed its run, we clicked on the Add File icon and on the form, and the Add File automatically loaded into Excel. Below is the Add File output from the Walk Forward Input run, sorted by total out-of-sample net profits, as I'm clicking here. This example shows the partial output file from the run on the Power Walk Forward Optimizer files generated when we ran S&P 5-minute bars with the robust regression velocity strategy from 1/1/2008 to 12/7/2018. That generated a total of 566 total out-of-sample, in-sample and out-of-sample files in the Power Walk Forward Optimizer run. I used those files in the paper trading the S&P 500 5-minute bars with the robust regression velocity strategy on my website. If you look under papers, you'll see that paper. Here, we're going to examine the output that was also in the paper that used those Power Walk Forward Optimizer files. I explained how those Power Walk Forward Optimizer files were generated in the how to use the Power Walk Forward Optimizer and the output of the Power Walk Forward Optimizer videos. If you're not familiar, just click on the videos and you'll see how they were generated. The in-sample period, of course, was 30 days, and the out-of-sample period was 7 calendar days or 1 week. On the row 1 columns, click here and describe. Row in column A that you see right here is just the Power Walk Forward Optimizer stub that we generated when we generated the Power Walk Forward Optimizer files. Column B is the start of the out-of-sample period, in this case 2808. The reason why it starts at 2808 is because the data starts at 1/1/2008. The in-sample period is 30 days and the out-of-sample period is 7 days. So we have 37 calendar days, and this date is the end of the first out-of-sample period. So the end of the first out-of-sample period was 2/8/2008. The last out-of-sample period was 12/8/2017. This is the period from 2008 to 2017 that we examined. We left out 52 periods or 52 weeks to see what would happen to the metrics and filter that we generated. What would happen to it on data that it never saw before? In other words, all these numbers that you see here before column Z were generated from 2008 to 2017. What we did then, this is all out of sample also, but we wanted to see that if we were there in, let's say, 12/8/2017, and we determined that 3 was the best filter to use, how would we have ended up in the next 52 weeks? As you can see, it was profitable. So we're going to examine now each one of the columns and what they mean. Row 1, column D, this is the total number of out-of-sample files that it used to generate everything below column Z. Any TMP means that I didn't use this metric. In the in-sample period, the total net profits could be plus or minus, but I didn't use that. I just used profit factor and K-tau. Number of 52 means that I withheld 52 weeks. In column N is the bootstrap average, and column O is the bootstrap standard deviation. Column P is the number of filters we examined. There was 193,535. Column U is the commissions and slippage that we used for each trade. If we go over here to column AA, this is the 52 weeks that we withheld. That was from 12/15/17 to 12/7/18. Obviously, AC is the number of weeks. T 566 is the total number of out-of-sample periods, including the withheld weeks, was 566. Looking at row 2 defines the definitions, the columns that you see below it. Column A is simply the inputs, which were N, V up, V down, XOP, XT, and multiplier, and the metrics that we used. The metrics were less than, profit factor less than, and K-tau less than. TOGP is the total out-of-sample gross profits. TONP is the total out-of-sample net profits, which is the gross profits minus the number of trades times the number of weeks times cost. Column D, the average out-of-sample gross profit for the 514 out-of-sample periods. Column E is the average out-of-sample profit per trade. Column F is the average number of out-of-sample trades per week. Column G is the standard deviation. Column H is the skew statistics of the 514 out-of-sample profits and losses. Column I is the kurtosis statistic of the 514 out-of-sample period profit and losses. Column J is the student T for the 514 out-of-sample periods. The higher the T statistic, the higher the probability that this result was not due to pure chance. Column K, out-of-sample wins divided by out-of-sample losses, is the ratio of the average out-of-sample winning trades divided by the average out-of-sample losing trades. Column L, percent winning trades, is the percentage of out-of-sample winning trades. In other words, every single trade in this period between 2008 and 2017, every single trade, the percentage of winning trades was 49%. Column N, percent P, is the percentage of out-of-sample weeks that were positive. So there was 514 weeks, 59% of those weeks were positive. Column N, the largest losing trade was period from 2008 to 2017 was minus $306. The largest losing week, the largest losing period out of these 514 weeks, in other words, the largest losing week was minus $722. The equity drawdown, the largest equity drawdown was $1,163. The largest number of winning weeks in a row, or periods, was 9. The largest number of losing periods in a row was 8. The number of weeks that this filter traded was 441 weeks out of the 514 weeks. What this means is that for this set of inputs, these metrics prevented it from trading, though the difference between 514 and 441, this particular set of inputs with these metrics didn't trade 73 weeks out of the 514 weeks. V20 is the velocity of the last 20 weeks. This is used as a measure to see if the curve was moving up or moving down. If V20 was negative, that would be a negative sign for us to watch ourselves because the curve is starting to trade down. Deviation squared is the measure of the equity curve smoothness. It's the square root of the equity curve minus a straight line squared, the sum of all those. And it measures how close a straight line fits the equity curve. It's another measure almost equivalent to the coefficient of correlation. K-tau, K-tau is the Kendall rank coefficient. It's used to determine whether two variables may be regarded as statistically dependent. This test is non-parametric as it does not rely on any assumptions on the distribution of the out-of-sample profit and losses. Equity R2 is the correlation coefficient R squared of a straight line fit to the equity curve. BLW is the maximum number of out-of-sample periods the out-of-sample equity curve failed to make a new high. Break even, BE, is assuming that the average and standard deviation are from a normal distribution. This is the number of out-of-sample periods you would have to trade to have a 98% probability that your out-of-sample equity is above zero. Beyond this line is the withheld 52 weeks. TOGPX is the total gross profit for the 52 future weeks that were excluded from the original run. TONPX is the total net profit That's the profit minus commissions of the 52 weeks that were not included in the run. AOTRX is the average profit per trade for the 52 weeks not included in the run. AOONTX is the average number of trades per week for the 52 weeks that were not included in the run. PoundX is the number of weeks that it traded. It traded 50 out of the 52 weeks. Total out of sample net profit is the sum of the 52 weeks that were excluded and the 514 weeks that were calculated. The probability that the future out of sample total net profits was due to pure chance. Row 1 lists the random bootstrap average of the 514 out of sample files. We can calculate what's the chance that our return was beat by a random selection return. This calculation can be done simply by multiplying. It's an approximation, simply by multiplying the total number of filters times the probability. And as you can see, this number is way less than 1. So it's improbable that any random selection would set of numbers from the 566 files would be able to beat profits from row 3. I basically chose row 3 as the best set of inputs plus metrics to use moving forward. I chose this basically because the student T was one of the highest student T's, although down here there was a higher one. K tau was 95%. Equity R2, the R squared was 93. Below was 54. It only took 54. The largest number of weeks that it took was 54 weeks to make a new high. This row seemed to me one of the best when you look at all the various metrics that it had. So in order to see what this looked like, we just click on row 3, and then we would go to add-ins, and we would click on this little icon here, which is included in the package. And as you can see, it has to go through 19,000 different little files, and boom, up pops a graph of the equity curve. And as you can see, this is the set of inputs that we use with the metrics for this particular period. This vertical line is the line that separates the 52 weeks from the 514 weeks that we use to calculate this filter. The top line, the blue line, is the equity curve without commissions. The red dots are the new highs. The brown line is the equity curve minus the costs and slippage. And the green dots are the new highs that it generated. I added a second order polynomial curve to fit both of these curves, the no commission curve and the commission curve. The second order polynomial fit with 93.5%, and the second order polynomial fit the brown curve with 90.36%. You can look at this curve, and one of the things that you notice is that after commissions and slippage, this thing from 2.516, well, actually from 7.816 to basically 9.1517 didn't make a new high. So I mean, that's quite a long period. Below that you saw on the original Excel file was generated from the non-commission curve. Nevertheless, this did pretty good. Any number of filters could be selected also. You're not constrained to just one filter. For instance, if I wish to see how this 5.86 filter did, it would simply highlight it, go to add-ons, click this icon, and that filter would also pop up with its equity plot, and which I'll show you in a second, it's how the equity plot was generated. These lines right here, let me change this around a little so that it'll be easier. What I was just trying to show is that you can click on any number of lines and they will just pop up as different Excel tabs, and you can look at them. But what I wanted to do here was show you the original one. So let me go back here. All right. So along with the chart is how that chart was generated. In this tab, we see what the set of inputs and the filters were. The out of sample date, for this out of sample of 7 days, the out of sample profit was minus $330. The out of sample number of trades was 11. The equity, which is the sum of all the out of sample profit and losses, was minus 30, obviously. The net out of sample equity is just this equity times minus 11 times 4. $4 was the cost of commissions and slippage. So this came to minus 374. And the net equity is just the sum of the net out of sample profits. So, if we go down to the end, we see that if you subtract the first line, which was a definition line, there's 566 total, and 500. If we go over here, 514. Actually, it should be 515 because the first line, the first row is a definition row. This would be our 12, 18, 17 numbers. So this shows you where the equity curve came from and where these numbers are. Back to the main screen, as you can see, there's a number of good filters, inputs plus filters, and I happen to choose row number 3. I generally look at, maybe the first 20 rows or something like that, and try to determine, given all these parameters, namely the percent of winning trades, the percent of percent of weeks that were profitable, the largest losing trade, the largest losing week, equity drawdown, winning at the maximum winning periods in a row, the maximum losing periods in a row. But I mostly rely on K-tau, equity R squared, below the deviation squared, and the student deviation. Those are the main ones that I look at. I try to have T as high as possible, K-tau and equity R squared as high as possible, below as low as possible, and break even as low as possible. And I like to look at the equity curve too and see if it's performing smoothly or not. This concludes this section on how to find the best set of inputs with their metrics using the Walk Forward Input Explorer. I explained it in a little more detail in my paper, but this gives you a good idea on how everything was generated. In the next video, we will examine how do you find the set of inputs and metrics such that you can trade next week. I'll see you in the next video.